Hi. Okay, today we shall be detecting serial correlation or autocorrelation in the autoregressive model. So here today we shall be detecting serial correlation or autocorrelation in the autoregressive model. Okay, what does mean by autoregressive model? Example, suppose GDP is the dependent variable and C is the constant. So GDP lag 1 and ER. Suppose GDP is the dependent variable and ER is the independent variable and GDP lag 1 is also independent variable, and this type of model is called autoregressive model because GDP is regressing. GDP is because the cause is GDP is regressing itself by 1 period lag, right? GDP is regressing itself by 1 period lag, and when this thing happen we can call it autoregressive model. I can give another example. Suppose exchange rate is the dependent variable, C is the constant, exchange rate lag 1 is the independent variable, and GDP also a independent variable. So here I have two independent variable, and this model is also called regressive model because exchange rate is regressing itself by 1 period lag. So this type of model is called autoregressive model, and that we shall be developing today, and we shall be checking whether this autoregressive model has serial correlation or not by using correlogram approach. Correlogram approach. Okay, and we have, you can see we have variables are here, ER and GDP. I can make it zoom for you so that you can see these two variables, exchange rate and GDP. We have these two variables, and here GDP is the dependent variable, and our sample size is from 1960 until 1990. That means 31 data is here in total. Okay, what I can do, I can make it big for you. I can show all the data. I select and open as a group. So this is the ER, this is the GDP from 1960 until the total data is here until 1990, right? So we have almost 30 years data, and it is a time series data. So here the serial correlation can be attacked, because normally when the data is time series, normally serial correlation appears, and normally heteroscedasticity does not appear in the time series data normally, right? So here serial correlation may appear because this data is a time series data. Okay, now I develop auto-regressive model. I go to quick, then estimate equation, right? I choose here. Then I write our variable. First is GDP, that is dependent variable, then constant, then GDP lag 1, sorry, GDP lag 1 and ER. So this is my auto-regressive model, and I can make it zoom for you. You can see GDP constant, GDP lag 1 and exchange rate. So this is our auto-regressive model, right? And now we want to estimate this model. So I press OK. It has been estimated. GDP is the dependent variable, right? Dependent variable. And this is the lag 1 GDP. Is it significant? Yes. It is highly significant because the probability value is less than 5%. So GDP lag 1 is a significant variable to explain our dependent variable. Then what about ER? Is it significant? No, because the probability value is 82.92%, which is more than 5%. So exchange rate is not a significant variable to explain our dependent variable. Then we talk about R square. R square is only 44.83%, meaning that data is not nicely fitted because R squared is very small. It is less than 60%. So the model is not nicely fitted. But the thing is that F statistics and the corresponding probability value is significant. You can see the probability value is less than 5%, meaning that although the R squared value is low, but F statistics is significant, then we can say GDP lag 1 and ER, these two variable jointly can explain GDP. That means GDP lag 1 and ER, these two variable are significant, are jointly significant to explain our dependent variable, which is GDP. Okay, here although the R squared is small, but we can accept the model because F statistics is significant. So we are happy about this model. Why? Because out of these two variables, one is significant. That means 50% of the variables are significant. And what is the guideline? The guideline is at least 50% of the independent variable should be significant to be a good regression model. And here at least one is significant out of two. We are happy about it. And secondly, although R squared is low, but F statistics has become significant, meaning that GDP lag 1 and ER jointly can explain GDP in the population. So we are also happy. So normally the guideline is if the R square is small but F statistics is significant, then we should accept the model. Okay, then we check. So this model is a time series model. So this model can be affected by serial correlation, right? Can be affected by serial correlation. And normally when the variable are time series, heteroscedasticity problem do not comes in. That means normally heteroscedasticity problem do not appear, especially when the data is time series in nature. So for this model we shall not check whether this model is suffering from heteroscedasticity or not. Normally heteroscedasticity appears when the data is cross-sectional, right? Normally when the data is cross-sectional, heteroscedasticity problem appears normally. And when the data is cross-sectional, then normally serial correlation problem do not appear. Okay, in our model can be affected by serial correlation because we have time series data. Now how to detect serial correlation? There is a one way out of many. We can check the Durbin-Watson statistics, right? Durbin-Watson statistics. So that is one way to check. And normally we say if the Durbin-Watson statistics is close to 2, then probably there is no serial correlation, right? That is the guideline. If the Durbin-Watson statistics is close to 2, then we say probably there is no serial correlation. And serial correlation is not, that means if the model is affected by serial correlation, then we cannot accept the model for prediction. Okay, but the thing is that, and we have the Durbin-Watson value here. You can see Durbin-Watson statistics. How much this one? The Durbin-Watson value here is 2.222, right? And that is close to 2. So meaning that there is no serial correlation in this model. But there is one problem. Okay, but the problem is that when the model is auto-regressive model, then we cannot use the Durbin-Watson statistics, because Durbin-Watson statistics is not suitable for auto-regressive model. So, for this auto-regressive model, we should use the Q statistics to check whether there is a serial correlation or not. Meaning that Q statistics is suitable for auto auto regressive model to check whether there is a serial correlation or not. Okay, now we shall be checking Q statistics, and the Q statistics is under correlogram, right? Correlogram, that is the Q statistics. Sorry, Q statistics is under the correlogram, and that we shall be checking now. Okay, sorry. Okay, correlogram we are doing now. Just 1 minute. Okay. Okay, so the thing is that I go to view to check the correlogram, and here I go to the residual diagnostic. Then I go this one, correlogram Q statistics, right? I choose this one. Okay, here is 16 lakh. Okay, no. What is the guideline? The guideline is normally we take 1/3 of the sample size as a lag variable. And our sample is almost how much? It is almost 30. So I take lag 10. That is the 1/3 of the sample size. So I make it zoom for you. You can see. So here I have taken 10 lag because our sample size is 30. So I have taken 1/3 of it. Then I run this Q statistics and check what happens. Okay, the result has come up. The Q statistics outcome has come up. You can see the probability has come up. Q statistics has come up. Probability has come up, right? Okay, and you can see this is the autocorrelation coefficient, right? Autocorrelation coefficient. So what about this one? This one means actually this spike. This one is actually this spike. At the same time, 0.004 actually is 0. So there is no spike, right? The value is 0. What about this one? 0.141 at lag 7. It is this one. Okay. And when this is all autocorrelation function, when the autocorrelation function is almost 0 or very close to 0, then we can say probably there is no serial correlations. We can say also the other way. So when these are called spike, right? Spike. So when the spike are within these two line, right? Within these two line, then we can say probably there is no serial correlation in the model. But that is a graphical decision. But we have to check it mathematically that whether there is a serial correlation or not. And we can check it from Q statistics and corresponding probability value. right? Okay, and what is our null hypothesis? The null is there is no serial correlation in the residual, right? There is no serial correlation in the residual. That is the null hypothesis. And here we can see Q statistics and corresponding probability value. You can see the probability value or p value all are more than 5%. Suppose I talk about this one, the p value is 61.3%. What about this one? 90.2%. So all p value are more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no serial correlation in the residual. So we are happy about it because there should not be any serial correlation in the model. Only then we can accept the model for prediction if there is no serial correlation. And here there is no serial correlation.